Thank you, everybody. It's an honor to be able to talk to you all today. And it's amazing that following on the last presentation, it was a perfect segue to what I want to touch on. And it's really moving beyond the static nature, if you will, of assembling models and turning into reality what we're trying to design through BIM, and look at that asset level in the realm of connectivity and what we as the users and consumers of assets can pull together and harness with the information. But to do that, there's some fundamentals. And I always say we can BIM anything, but if we don't have the foundation in place, we're going to be BIMing nothing. So very, very quickly, BIM is your noun and your verb. You can assemble. It's this process, the data that's derived throughout the life cycle of a project, design into construction into operation. It's also the models, the collection of information. You have to collaborate and plan. Very critical. If you can't collaborate, you can't share the information, and if you can't share the information, you can't do more with it. Geometry plus data equals BIM. Simple as that. And the geometry is critical. I don't care what it is or where it comes from. Understand that there is geometry that applies to the assets that we're modeling. We focus a lot about how the buildings come together. So we have all of these consultants, contractors and subcontractors, architects and engineers, sub-trades, pulling all this information together. So we can do things like the 4D scheduling, cost estimation, drawing, specs, etc. That's great. Now let's deconstruct it again. Where does all the information come from? But more so from that component level. What are we modeling? Why are we modeling it? If we don't know what we're modeling, we don't know what we can actually do with that asset. And then think about the geospatial connectivity. GIS is phenomenal. You can do so much with GIS to geospatially locate your asset in the built form. Here you have an element, but it's not just a guardrail, it's part of a bridge, part of a road, part of a network. In the spaces we are today, you're all sitting at chairs, at a table, in a room, in a building, on a street, and then we can go as macro as we need to. Every single element put into a BIM model has a macro to micro relationship to its geospatial location. Then it's about multiple sources and streams of data and information. You don't jam everything into the BIM. There's sourced data from various locations. What is it all? Where does it all come from? What's the glue that ties it all together? And once it's all glued together, then what can you do with it? So then why BIM? You have multiple BIM uses. This is what I use internally to IBI. There's different semantic vernacular. It doesn't matter. The point is, know what you're doing, know why you're doing it. For me, we define base versus typical versus custom. I'm talking about the asset management piece today. So focus at the foundation and that point of why we're working with those components. And don't dwell on software. So software, regardless of the vendor you're using, you have building software, plant software, civil software, all with varying degrees of data interoperability, analytical capabilities, and synergy across the applications. When we look at the BIM world, we'll say, we're never really BIMing in one application, and I've never really been on a project that did. So if you're sitting there saying, well, we've done full Revit projects, but there's had to have been some interaction with site. The buildings don't float. So something had to provide some information in the linear infrastructure. For me, you find whatever that collection is, you wrap it around your platform, and then you focus on where's that data going. Where else it may be going, and how are you getting it there? And the how you're getting it there is the critical piece. What's going there and why, and what is there? And there is changing exponentially as we keep looking towards the future. We have standards that are trying to drive data synergy. So if I'm using Revit, EcoSim, Graphisoft, Civil 3D, Plant 3D, OpenPlant, so what? That's great. Let's pull that data together. Assets can be sourced in various applications. It all doesn't matter. Where's the data going? Then to collaborate. A lot of talk about tools and systems and cloud versus hybrid cloud versus WAN versus LAN, all good questions. And I'm not even going to pretend to say the industry has all the answers. But sometimes I struggle with getting an answer to question number one. What are you sharing? And then where? And with who? And then who's accountable? Simple questions, in theory. BIM execution planning, all valid. Oftentimes, especially here in North America, we skip step one. And step one is so critical. What are the owner's requirements? Who are we turning this data over to and why? And then are we able to do it? And if we're able to do it, Now let's plan. If we're not, the plan has to accommodate an understanding of what we're doing and why we're doing it. And then keep in mind your project delivery. BIM is not an ominous process that works outside of the realm of scope, schedule, and budget of a project. That all has to come into play. It's supposed to enhance quality, not explode quality, and not diffuse quality, causing an implosion on the triangle. That triangle is from the project delivery standards. So talk about the asset now. So that's in my brain, that's what BIM is. That's how you rationalize it, that's how you plan it. Now we can get to the component level. Asset management into and itself is its own beast. It has its own ISO standard. For me, the important message is the cyclic life cycle delivery of you acquire an asset, you operate it, you maintain it, and you dispose it. And that happens over and over and over again. And through the acquisition and operation, BIM plays an important piece. So that cyclic diagram is being infused by asset information, and that asset information includes the BIM model, includes all of the data streams that we're gluing together, and includes other asset information that influence either the operational nature or the capacity expansion of an asset and what drives what we're doing with it. So all of that's governed by an ISO standard, so globally, hopefully when people talk about assets, there's synergy to that. In IBI, we said, so what? What does that mean to us? So IBI, we have buildings, intelligence, buildings, and infrastructure. So we have three facets or three sectors, if you will, to the company. And we all got together and we said, okay, so what does this asset management mean? In the design world, what are we doing? And you can see we have the BIM stream. So there's BIM information, but there's all these other streams of information, including how to manage the asset record, how to monitor floor plans when we're doing buildings, so spatial and room efficiency studies. We want to tag the assets, track the assets. Where are they in the linear geospatial world? Where are they within the vertical infrastructure of buildings? How do you account for that? Track the maintenance and operation, track the financial planning of the asset. All information pertinent, again, remember, we're taking the BIM model and we're blowing it up down to that component level. Each and every component that has an asset importance to an owner has some stream of information from various sources. How do we glue all of that together? That's the focus of what we're looking at. We're not unique in this, so this is a wordy diagram, a wordy slide, but this is what the UK defines as where BIM fits in. So the simplest form in asset management, BIM shows you where the asset is. That's cool. You can do a lot of other things with it, and I keep saying BIM can help to be the data glue. The thing that glues streams of information together, portrays you virtual awareness, and portrays you as maybe a portal to other asset information. This is the BS 1192 diagram. In the UK, they've mandated level 2. They're looking at level 3. I like level 3, the concept of the informational BIM. So you take all that information, jam it together. In the same document, there's this diagram. And I find this one to be far more powerful because the UK has defined that you're going to go through design, construction, operation, and that asset information model is something that's going to grow over time and represent both graphical, non-graphical, and documentation fused together, informed by the owner-operator, or as they call it, the employer, and then go through that cyclic function of, do we need to expand the capacity, and if so, drive the planning, design, construct, operate, redefine the assets, refuse the information, and pull it all together and continue the cycle. And there's an interaction there through the supply chain of consultants, contractors, as well as the employer chain, which is the owner. Very powerful side, and conceptually it's spot on in my opinion. This slide came to us, and I have I can't see, too small there, but that's the quote of who it came from. But the concept of an asset's failure zone, and I think that's a critical piece to understand. So the asset's going to live far beyond design and construction, and one of the points of asset management is to inform decision making from the owner's perspective. Connect them to the information, allow us to infuse the data together, allow them to understand what's happening to the asset. And that's a critical piece when we start to think about cognitive BIM and digital connectivity. So what's that asset done? What's been done to that asset throughout its life cycle? And when do we have to start to think about replacing it? And what does a replacement mean? So this graph is showing replace it where it's green, you're more economical, there may be replacement value. So buy a new component, sell the old component, the new component might bring new functionality. But what about the behavioral nature of that asset? When I'm replacing it, do I want a new component, a better component, a different component? What did the users do to that asset? How often was it maintained, fixed? How often did it break down? And answer those questions. And where are the answers to all those questions? If you wait till the asset fails, you're in reactive nature, you can't redesign, you can't analyze the data, no resale value, and you're probably just gonna get the same asset with the same potential failures. So this is a convoluted slide. I just wanted to put it up here to understand that the information about the asset is going to be obtained at various stages in the design. Now, I don't want us to all get lost. Am I using REBA? Am I using AIA? Am I using percent complete? It doesn't matter. They're all saying the same thing. 0 to 100 to your design, you construct it, you operate it. The REBA phases, the AIA that I highlighted, they all map to some type of percent complete. I show this slide because the next set of slides, I want to go through a story of how you can answer, so what? So you're saying, think of the asset, what does that actually mean? When I was on the London Olympics, we went through these slides. So these were diagrams we pulled together. On the right, I'm showing the REBA phase and the AIA. So this is at 0 to 10%. And we started to say, okay, great, we have a design, there's a need. Let's talk about that. So you start with an appraisal, this is what the building's about. And you start to lay out, think about spaces. There's no model, there's no anything, but the design is starting to progress. You're at 0, 1%, 2%. There's a programmatic issue that needs to be created. You start to get a design, and focusing on the mechanical end, watch the purple box. We have a bunch of mechanical systems that have to go into play. Some schematics that are being drawn, still no asset, but design is progressing. Now all of a sudden, inside the mechanical control, we've started to define some specific needs. Still no asset, but ideas. And those ideas are the foundation of asset information, starts to form. Whatever's being decided here, we're in design development, going into contract documents, this can't get lost. So we've now defined in the specific system, there's 3 types of pumps. Next phase, specific to the one pump, we know the make and models and the types. So we know what we're going to specify. We know what's going to be there. This information is starting to grow. We're now tendering. We know what the item is. So more information. It's now been chosen. It's been bid. It's now going to come to site eventually and get mobilized into a model number. We now have model number, serial number information. So the asset information has grown right now. This is through the design and construction lifecycle. There's a lot of information getting from obviously initial design to contract admin. When you're on site, the component is there. That information tends to get lost. Or where does it all go? And part of the problem with owners is that they'll come to us saying, well, we don't know what's been on site. We don't know how it was designed. We don't know what was installed. Or they may know what was installed but not have the design brief. So this is the foundation of asset information, but it doesn't stop here. One simple phase called operations that spans the life cycle of this item. So much will happen to that one asset and every single one of its brother and sister assets throughout that facility. And where does all that data go? If the BIM stopped at K there, then you have a severance of information. And then not only will something happen, but it'll continue and something will get disposed. Parts will change. Maybe the asset itself will be replaced. And how do you track that information? That is this whole asset management solution, and trying to fuse data together so that if it's there in its entirety, we can then spawn it off to something more powerful. Because as the previous presenter just was saying, everything is connected. So all of that information now, spanning design, construct, operate, the excessive lifespan of operate, then into disposal, is all tracked, connected, and maintained. And there's user interaction, human interaction. There's people causing the change, there's financial reasons, there's usability reasons. And where's all that data? And what does that mean? How do I know what to do with that asset when I need to change it, or if I need to change it? That's what this all comes together into this digital economy concept. No matter what you do, you're connected. So the life cycle of the asset, we focus on that initial. So we did a couple of studies, this 21% concept. This is where all of our effort is going with this BIM right now. And that's great. We design and we construct. And when we sit internal to our design teams, we say, look at the little speck of influence we have on the life of those components that are going in our models today, as architect, as engineer. What about the rest? And what's the relationship between the information that we started for that first 5, 10%, 20% in construction to the rest of its life? Why is there a break? Why is there a severance? And in the digital world today, and looking forward, I'll argue that that's probably not going to be acceptable anymore. That information has to be connected. We can't have a break to say, well, we don't know we don't know the decisions that drove the asset. We don't know why it's here. We don't know where it's going to go. We've got to have data fusion. And I would say data fusion is where what we're going to see in the future. So at IBI, we stood back and said, okay, so what do we actually do? And what does it mean to how we function? So we'll say we bring, in any design firm, construction firm, will bring expertise to certain facets of the industry. So we kind of broke up our sectors and say, yeah, we have urban, facilities, transportation, and intelligent systems. We have those focus. From there, we derive where we can apply the expertise, hopefully resulting in some type of result beneficial to the industries to which we're serving. Now, those results are the target. Now, flip that. It's about the asset. For us to provide expertise, we have to understand the results. So if you turn that around and we say, think of just the results only. I want to influence the people, the economy, the environment, the mobility, help governance, improve living in the areas that we're looking. Well, how do I do that? The example we say is when we're doing a condo design, who are we designing the condos for? Millennials, baby boomers, what are the needs? What's the influence of social media, lack of cars, Airbnb, grab a car as you go? Do you need the same type of parking? What type of amenities do they want? How does that drive how we design? Well, let me look at condos we have today, but wait a minute, they're not designed for millennials. So what am I looking at? So why don't we look to understand, well, what are those results? Let those results feed how we apply, then mold our expertise. So we look at this and say it's got to be a focus of understanding from the user perspective how those assets are being used in the outside world, feed that to us internally when we're trying to understand what we're going to do to that asset. And that's the hard part, is to know and predict what's going to happen to the components we're designing throughout their lifespan so that in turn can feed how we design them. So it's that vice versa, pull the information in order for us to push the expertise out and have a net result of influencing the output. So how do we do that if there's no continual data, there's no information synergy, and there's no ability to connect to the information about that asset? How do I know how a condo is being used? How do I know that the space that I've designed is being used as I thought? How do I know what the users are doing? I'm in an industry, I did a lot of work on industrial plants and a lot of talk on, what pumps do we spec and do the pumps right for the flow stream? How do you know? How do you know what the right answer is if you don't have an historical representation of what happened to the components that were put in place? So if BIM is truly a collection of assets, and remember my first slide, object plus data. That's all that BIM is, if you put it to its utmost simplicity. That data is what's scopable. So if BIM is that collection, what does that mean to us? This slide I made, goodness, a decade ago now, and there was a lot of talk about, well, what does this actually mean? You have a model, and we used to say in 10 years ago, the model will live throughout the duration, right to the very end. You design, construct, operate, and then it will die, it will mold, it will change. So what did that actually mean? So there was always the argument, well, how can my Revit model go and get adapted and get passed on to all these various people, this single big monster? Then no, you can divide it in pieces, it'll be facets, it'll be this. And this was when we were on the London Olympics, when I was on London Olympics, not IBI. it adapted to, well, really, it's not the model, because there's going to be tons of models. There's going to be tons of sources of information. It's about that asset. What are the assets of importance? Which ones will grow? Which ones will have data streams that are collected throughout the life cycle of its existence? And what's the important data? How do you fuse all that together? How does the model grow? And then what parts of the model are okay just as they were? So it's not about, here's the model, here's the file, which is a big conglomeration of components, but every single specific component that's important to an owner, it's about those facets, and they continue over time. So this slide, this was cool. I sat down with our asset management team, and I said, so we talk about all this stuff. What does that mean? So what does a user do to an asset? So we looked and we said, well, the asset has to be financed. It'll go through design, build out, be maintained, and replaced. And then we were trying to give examples of activities you would do during design, construct, operate, dollar implications where you might have an influence. And then we stepped back and we said, well, good, now why do I care? We made this slide, why do I care? And we said, well, an owner will look and say, I want to know what I have, what's its condition, how do I operate it, and maybe how much did it cost to procure, maintain, replace? How do I tie all that together? So we said, okay, if that's the value, so what's in the BIM model? What's in an asset management system or a CMMS, computerized maintenance management system? What's in all of these repositories that need to be tied together? So notice I keep saying tied together, glued together. I don't know how many times I've said that right now. But that's the critical thing. You're not trying to infuse everything into an Uber solution. You're trying to glue the information together so that it can be of value to a consumer, a stakeholder, or an other entity. So we looked back and we said, well, here are some of the areas where, the BIM model versus, let me go back there. So we have the BIM model in red, a management system in green, financial purple. So we tried to map some of those areas, and we said, well, based on that initial concept diagram, we know we're going to have these various systems, and they'll all be glued together now through unique IDs, through inputs, through interfaces. So we said, that's great, and then it gets back to that component level. What am I, the user, going to do? I want to first find information. So if I'm going to my laptop, the table, the podium, whatever it is, I want to know something about it. How much did it cost? How old it is? If there's an issue with it, what do I do? Who do I tell? How do I interact? So the concept of the barcoding is something we're looking heavily into. The barcode, to tie it to a virtual representation. So the virtual representation shows where it should be. The barcode shows where it is, either in a GIS system or using virtual reality. Tie me to the information, tie me to other databases. Basically connect and glue all that information together. If that happens, I can now interact with the asset. So the cognitive nature now comes into play. So the idea here is, how do I take assets now and have them either be informed by or adapted by behavioral data or behavioral actions of their users? And with some of the examples you've seen earlier today, and I'm sure you will see today, this technology exists in other industry, but for me, it starts at the data as the communication mechanism, something for me, the user, to connect with that asset and say why something's wrong. We're toying with a system now where we're tying in work order ticketing along with our BIM model, along with asset management records, and having that data be tracked and then inform to the output of our design, to the starting point of our designs, to tell us how the assets are operating. And then more importantly, if I, the user, wanted to change the asset, how can I do that? And that's where the cognitive nature comes in. So if the assets are together, we know where they are, I can start to interact with them. So imagine in a room like this. So right now, those lights are driving my eyes crazy. So why can't I, the user, interact with those two assets in a different manner than everybody else? So why can't we set lighting levels according to our users? Why can't we adjust mechanical systems according to each of our users? And how would I interact? What's my interface? I have a digital device. My iPhone knows who I am. Why can't I enter a space, interact with the assets around me, and customize them for me, in conjunction with everyone customizing it for themselves. And if we could achieve that world, what does that mean in the design? So what does that mean when I have an air handling unit blowing air into a space? I now want to customize it for the potential occupant load of the space of 100, 200 people. What does that mean? And those impacts are something that we need to really start to think about looking forward at the design and construction world, because it could change the nature of how we make our buildings and the infrastructure behave, and it'll change the nature because we're thinking of the people we're targeting the behavior to. And that's all through this digital economy connectivity. And I keep coming back to that. Everything's connected. Every asset has its place in the digital world. So for us, it's this back and forth infusion of the result to the expertise we're trying to provide and making it mold together. So if you have a very simple diagram here, you have this BIM model. Think of it conceptually now. You know, we have this end user product, this interaction, this digital nature, the Uber, the Airbnb. What's that digital interaction between our users and the assets? I'm not going to say the building, because it could be the transit. It could be one of the assets in the building. It could be buried infrastructure. What's my interaction with the valve that's 6 feet underground, accessible by manholes at the other sides of the street? Well, how does that work? Then if I know that interaction, then I, the end user, will now start to influence either the operation, the asset itself, maybe force a change, maybe track the failures, track the maintenance, infuse that back, and redo that cycle. So remember the asset management: acquire, maintain, operate, replace. Inform that cyclic nature for asset management. So this promise, when I was at the BIM World Summit, they talked about what's the promise of BIM? What have we been saying from day one? BIM is this model that can grow over the life cycle of a project and be rich with information that could be turned over from design to construct to operate. The owner has something phenomenal at the end of the day. That was the promise, and it still holds true, but you know, it's at the data, the bits and byte level, the data of the asset, synergizing it throughout its life cycle, and putting that into a user-aware situation where now the asset themselves can have a virtual dialogue with the users that are interacting with the asset. And we're going to get there. It's not far-fetched. It's actually in reality. And you've seen your houses. You can have virtual interaction with your lights, and it could all be retrofitted to connect to your smartphones and respond to yourself, differing from your spouses or your kids or whomever. So you can start to have that dialogue, but let's see that now at the macro level of how all the assets infuse together. So buildings can talk to your energy providers, understanding how I, the user, interact with my building and adjust the space. Cooperation with other facets of the neighborhood. And for me, that's an intriguing one. I always would argue that, you know, whenever we design buildings specifically, they're never in isolation. So every time when I hear, hey, here's our Revit model, and I'll say, well, where's all the other information that the Revit model will interact with? The building must sit in a site. It must connect to something. And all of a sudden you have neighborhood connectivity. So how does the intelligent connections and how does the movement of the assets, the flow of the assets, the usability from one to another? Remember, in the neighborhood perspective, the building is nothing more than a big asset. It's just one piece of asset across all the other assets. How do they all connect? And what's the interaction between them? IBI has some work with smart city infrastructure. And for me, the infusion of BIM into the concept of smart city, it's a very logical progression forward. Again, if we understand it's about those components and what's being done to them, we can very easily tie and glue data together that would then inform any facet of what's being interacted with at a smart city level. This image is from the BIM World Summit, and the dialogue was phenomenal there on that synergy, if you will, between the usability of our assets and the outputting, the connectivity within the digital world or the digital economy. So if you think about that, I put this one together. A lot of work on BIM authorship. I'll always say, I talk about all this stuff, and when I walk around an IBI office and I hear I still can't print from my Revit model, well, we're going to work on making sure that we can do the fundamental things we have to do. But BIM authoring is just a small piece. generic BIM, there'll be talks about that, IFCs, ISO 15926. It doesn't matter what you're authoring. I want to take the models with those, so graphics plus the information, pull them out of the authoring tools, put them together in a generic open BIM fashion that's then exposable and can be interacted with the outside world. So in IBI, we did that with our asset management team. We gave them IFC files, we gave them data drops from various models, Revit and Civil 3D, and we were able to infuse those together and interact and build systems and actually have ties between the modeled assets and asset management records and work order ticketing. So you can start to see the glue together and then interact with such systems and expose those to our clients. And that's just in the generic asset management. Data analysis. Now that we've done that, or now that we can get to that point, what do you do with that information? What am I going to do with 2 years of data for this podium telling me how users have interacted with it? Maybe the podium's a silly example, but look at any component around the buildings or the infrastructure you're designing. If I have 2 years, 5 years, 10 years of usability data, what do I do with that as an owner? How does that feed maybe how I put out an RFP? How does that feed what I ask for when I need to do a retrofit, a redesign, or even a new greenfield project? I can look at the information. Why do I have a pump in one plant that's failed 10 times and a pump in another plant that's failed only once? What's the difference? They're the same pump, but what about the conditions around? Is it maybe the operations staff? Is it some other particulars? What was the nature that made one fail versus the other? It was just bad components in the bad pump. Who knows? That's the analysis. And then the social interaction is where we are into this digital economy. The social interaction will tie together what the users are doing to that asset, how often they interact. So if we're in a space like this and all of you had an app and I said, if you're all hot, just put in a ticket. Just say, this space is horrible. So if everybody in this room said the space was too hot, we can go back and start to analyze, well, why? What does that mean with the assets? I would put tickets in about those lights right now because I think I have a headache. And we would analyze that. What can we do with the lights to change the nature of how they work so that me up here as an asset of interaction here could have a different user experience, a year down the road, a month down the road. And that fusion, that synergy of data to and from is something that will always, because the data will never change. Social interaction will be dynamic. The minute I say, great, I have an understanding today, tomorrow, there'll be a different understanding. There'll be different users, different criteria, different feedback on the asset, and all of that can be analyzed, pulled together, and allow us to make some more informed decisions. So is this all rubbish? Well, I would say no, and hopefully you all agree no. I was inspired by, I think it was the Lincoln MX, one of their commercials, and where they just show the hatch opening. So I think it's all the Ford cars you walk, a lot of cars now, you go, it senses you, the hatch opens. That's awesome, right? But then it said, but with this car, not only will the hatch open, it will look at your height and it'll open to the right height so that you don't bump your head and you can go and it'll adjust, but it won't go too high so you can't reach it to close it. And I listened to that and I said, what a phenomenal interaction between user and trunk. And it's such a small example, but imagine that exponentially applied to all the assets we interact with. And then how does that feedback how we design, redesign, and make new assets and redeploy and just change the way we're thinking of how the world works relative to the built AEC infrastructure? Because we're all the consumers, we're all the users, and it really should be adapting to us. So that's what I'm saying there. So end users, it's all about those end users, and the end users can feed the start of the design as opposed to the end users having to take whatever is designed and they would then have to adapt to something that may or may not work. So this is similar to the previous presentation. Went from paper to documentation, and I'd love to say we're at the point of optimization where BIM, been there, done that, we're all awesome at it, we're totally optimized and efficient, and I say that facetiously. I know we're not there yet because we still sometimes can't be efficient with it, but that's what we're trying to get to, because today and looking forward is not just about being optimized in the BIM world, but it's about having pure connectivity in the digital environment to everything we're doing, and I mean everything, and it's beautiful and scary all at the same time. What that will spawn to, I have no clue. But that's exciting as well. So let's say we had this conference 5 years from now. Hopefully it doesn't take 5 years. And Connection has been there, done that. Everything we design, we make BIM models. Every piece of that assets in the BIM model is 100% connected to some downstream system. We have a connection to social data streams, whether it is through simple things like Twitter, LinkedIn, Facebook, or whatever the new one is down the road. All the users are interacting with the assets with intelligent devices, with the iPhone 15, whatever it is by then, and we're all good. What will that lead to next? So what do we do if there's 100% connectivity to everything we're designing throughout its life cycle? We'll then be able to tell stories. I've analyzed all that data, and it's now molded this brand new project. So we're designing a condo building, and we looked at the owner's needs. We looked at user usability. We looked at statistics of previously successful and failed assets. We tracked all of the information. We took all that data and allowed that to inform what we're about to do now. And here's our brand new project. So that's predicting the future. Don't know if it'll happen. Thank you, everybody.